So in this example, we're going to see how we should manage memory in C++. We're going to try to be a little more simplified in our output than we were with the previous example. So here we're not going to be doing as much with output as we did before, but I think this should give you sort of a cleaner syntax-wise view of what needs to happen when you're writing classes that allocate memory in C++. So we have a myMemory class that has two pointers and a name as members that are all private. And then our constructor, we set the name that's given, and we could put defaults on this if we want, but I guess we'll leave that out for now. Then we set A to be a new integer that's equal to the size that was passed in, and then B is an array, so we'll allocate that array and do some initialization of those values. We have a print method that prints the name, the value of A, or the value that A is pointing to, and then also the members of the B array. And in our main method, we do two instantiations. One is with value semantics, where we have a stack variable, and the second is using reference semantics, where we use a pointer and then allocate that on the heap. And then we print both of those. So if we compile that and then run, we can see what the output is. Now, of course, we're not complete because we definitely need a destructor and we also need some additional constructors. So let's write the destructor first. Again, we'll start with a tilde, my memory class. It doesn't take any parameters. We're going to delete A. We're going to delete B. And that's because use delete when you use new with brackets. And let's set A equal to null pointer. Let's set B equal to null pointer. So that way, if there does happen to be a pointer to this object, once this is done, it's going to not give you access to what memory was allocated before. Yeah, destructor, regular constructor. Actually, let's put some defaults there while we're here. So our copy constructor is going to take as its parameter a const myMemory class reference, and I use original. So that's the object that we're copying. And let's move this up with the other constructors. So here in this copy constructor, I'm essentially going to do all that was done in the original one. So I'll copy those lines. Now, the first thing though is remember we were initializing the name in our original constructor. So we need to make sure that we set name equal to original dot name, and let's append copied to the end of it. And I believe that that syntax will be allowed. Yeah, okay. So and these are all bad, but that's okay because this is going to be original dot A, and this is going to be, if you remember, the size is stored in original.a, but we could actually just set this to be A. So A does hold the size, so that's good. So the size here is the original size, so now that's the new size, that's good. So the rest of this code is the same. I don't think that wrote. Did we lose our destructor? Okay, that is odd. The destructor wound up at the end of the program. which is not quite what I had intended, but, and I'll tell you what, let's do. We'll delete these before we complete this, but let's just say, we'll just say constructor, and we'll also do the name. We'll do copy constructor and the name, and then we'll do destructor and the name. Now we'll delete this before we're done because again, we don't want to get in the habit of doing that a lot. But it makes a good example of when all this is getting called. So let's compile this. And I think we did S. I think we want that to be name so that it's consistent all the way around. Yeah, so now you can see we get some constructors. And let's put an end of line there. Okay, so notice we're not calling destructor for C1, so that's bad. Or it's at least C2. So let's delete C2. Okay, and then let's set up a function just so we can see the copy constructor getting called. And I guess we can just say and then we'll call xprint just so that we're doing something. And that should trigger our copy constructor if we call that actual function. Now you can see that it does do the copy constructor, and notice that becomes my memory class C1 copy instead of C1. And so it doesn't cause any trouble with the memory like we saw in the destructor example, the first destructor example. Now suppose we want to do something like this. I want to say my memory class C3 is equal to C1. So let's do a copy constructor. And I copied the wrong version. Let's also copy it. Let's do C3 as well. So we've done an assignment here, and we've also called it twice with a function. So let's see what happens. So notice that when we do that assignment, it calls the copy constructor. Okay, so now let's say that my memory class 3, and let's just go ahead and initialize it with 15 and C3. Okay, so you can see what's going on here. So here's our original stuff. Then when we call the function, we get some copies, and then finally the destructors all get called at the end here. And actually here, I think that'll be good. I don't know why that didn't, must not have saved. Yeah, much better. So yeah, I think all this looks pretty good. So here's where we're calling the constructor and so forth. Now suppose we do this. So after we've done that, let's go ahead and print C1 and C3. Looks like I have too many new lines there. Those are out of order is why, but that's not important yet. So now notice when we do that assignment, nothing happens. And why don't we, in our print command, let's print what those variables actually are. Let's see if that creates too much of a mess. I don't think it will. Yeah, so I think now we can see what those variables are. So when we do the assignment, notice nothing actually changes. And I don't think that's necessarily what we intended to happen when we did this assignment. C3 is equal to C1 because notice C1 is to it, it's pointing to these. Now, what exactly do we want to have happen? Maybe we want C3 to point to those, or at the very least, maybe we want C3 to get all the values there. So we can create what's called an overloaded operator. And we'll talk about those in the next module, but here's an example for now, just so you can see what happens. And that's going to return a myMemory class reference operator equals, and it's going to take a constant myMemory class reference. And just like with the copy constructor, we're going to call it original. But I think it really just needs to do the same thing that the copy constructor does. So I'll copy that code and put it here. And the one exception is instead of this, I'll do assigned. And I'll note that this is the assignment operator. So let's compile our code. And it's not getting called. And the reason for that is I never actually did the assignment. So let me back up here. There we go. Thought I was getting a really good default one. Okay, so let's compile and run. Yeah, much better. So look at these values. Now they're the same. So this runs into the same problem we had with the copy constructor. If we have our assignment operator, so we have a problem here. So that's so I did do quite enough here because notice with my assignment operator, I'm returning a reference. So the first thing I want to do is we want to make sure that we're not assigning two things because we're actually going to allocate new memory here. So we want to make sure that what we're getting called on is not equal to the original function. And of course, if it is, then we don't really need to do any additional work. So we can just return this, the current element. Otherwise, that's when we need to do this additional work. And it's probably better to put this in a try block. And if something goes wrong or catch anything, and we'll throw those, or we'll throw that existing exception. Let's do that for A and B, because we don't really know. A could succeed and B might not. So we'll put them both in a try block, in their own try block, just in case. So then this should check that they're assigned. Yeah, I think that's good. And of course, if we have an error here, we need to delete both of them. That should work. Yep, so there we go. Notice now we get the assignment operator, and now notice they have different memory. This is C1 assigned, and that avoids some issues that we might have had before. So one other thing, though, we need to consider is, right, we're getting into the weeds here with memory, but a little sooner than I had hoped, but that's okay. What happens, though, this is going to get called when we're doing assignment. So this already exists. So I think we're also going to need to, before we do this, we want to delete A, and we want to delete B, because we want to free up the existing memory. There's probably some issues with some of the order I'm doing this in, so we could run into some bugs. Let me think. Oh, you know what? I think here's what we'll do. Instead of doing that here, let's do that at the end. We'll set up some new pointers. We'll have a int pointer for new A, and same for new B. And this will be new A. This will be new B. And then this needs to be new A. And then here, we actually need to delete A, and then A is equal to new A. We're going to delete B, and B is equal to new B. Okay, so again, this is a lot of really complicated stuff, but we want to think about all the cases we need. So new A, actually, yeah, let's do this. I think we can clean this up this way by just, so we'll try to get the new A, and if we don't, we'll throw. And then we'll also get new B. And if that fails, I'm trying to think if delete would work there. My concern is if that returns a null and then I try to delete it, I'm not actually sure what'll happen. So I won't delete those. I'll just do them both. I think that will be sufficient. But it's not, because so that's going to be, we're going to have to use original A here because we don't have new A yet assigned at this point. Okay, so we have that. I think that's good. So then what we're doing in this assignment operator, right? Remember, this is already exists, right? We're doing an assignment. The object exists. And then original is some other object that we're saying our object is equal to this here. And this is actually, I think we should call this, it's not really original in this case. It's actually a new object. Or we'll call this other object. Maybe that'll make it a little more clear. Okay, so here's my assignment operator. So first off, if I'm assigning something to itself, and that's what this checks, then we're going to not do anything, right? Because, okay, nothing's changed. Otherwise, I'm going to allocate two new integers. And I also don't want to do this name yet either. So let's do the name at the end as well. So then I'm going to allocate new memory for A and B. And I'm going to double check that they work. So now if I get to this point, I have new memory for A and B. Now I'll do the assignments. And then I've changed the name. I assign new A and new B to these new values. And once that's the case, I delete the existing A and set them to the new value. And I think that should work. Let me double check. Okay, so we have all sorts of issues. So I'm missing right here, I think. That actually could be the whole thing. Or not. So it doesn't like that. That might be good enough. Nope. Yeah, so that right there, I was dereferencing it, but I don't. They're both pointers, so I don't need to dereference that. And that could be it. New B may be uninitialized. Well, what about new A? Trying to think how new B would be uninitialized here because I think that's just a could. I don't think there's a path because we're going to throw if it doesn't get initialized here. So I think we're okay. Let's try to run this. And apparently we are using it uninitialized. Here's my assignment operator, and we're not getting new memory. So that's weird because we did in the past, before we ran into all this trouble, we did get that to work appropriately where it created new memory. So why is it not doing it now? Because it is doing the assignment operator. But again, we would expect these to be different. So the values are the same. So here, those are pointers, but I'm actually trying to get the value here, not the pointer. So I think that's going to be the bug. Yeah, so this is where it's not liking it. So I think I'm going to go back and do what I had before, where I'll do a catch here and another try for new B, and there I'll do them both. That way, just if there's a problem with one, I'll catch them both. I won't have trouble. And then I have more of these. So I need to close my try, first try. So again, what we're doing here is checking to see if we can allocate A, checking if we can allocate B. If we can't, we delete them both and then throw. So 57, it's saying uninitialized. Yeah, so I think if something goes wrong, I could just say if new A not equal to null pointer. I'll do the same for B. And then we'll initialize them to null pointer. And then I don't think I think we'll be in good shape there. Yeah, so now let's run it. Everything looks good. We're allocating new memory with our assignment operator. So I think everything here is good. I know this was a little longer than I had anticipated it being, but that was just because I came up with some additional changes with this assignment operator. So you can see the assignment operator can be pretty difficult, but you've got to do all of this. So let's reiterate what's going on here. I check to see, am I equal to what I'm trying to assign to myself? And if I am, there's nothing to do. And then I need to allocate new memory for my members. And I'm double checking to make sure that that works because again, if this fails, I'm going to have wasted memory. So if I've allocated that memory, then I'm going to set my name equal to whatever the other object's name is with assigned at the end. I'm going to take their size and generate a new array with the same values that has. And actually that should not be this, it should be other object BII. And let's make sure we're not doing that in the copy constructor too, because Yeah, that should be there. It should also be original BII. Yeah, we don't want to. We're not trying to create new values. We're trying to take what was there. So if those were changed. So this, we're actually creating those new memory objects. Then we're freeing our existing memory object and assigning our memory object to the new thing that we just allocated. So unfortunately, all of this is required in an assignment operator. This got a little out of hand. You'll sometimes see something called the rule of three, which is actually the rule of five, and we'll get to that later. But this rule of three means that if you have a destructor, then you need a copy constructor and an assignment operator. Or if you have one, you're going to need all three if you actually require them. So you do get these by default, and if you write your code in a certain way, and we'll talk about that later, if you write your code in a certain way, you can actually just use the defaults, they'll be fine. But when you're allocating memory like this, then it's up to you to make sure you allocate the appropriate things. That is a quick overview of how these things work in C++. And I guess I'll go ahead and leave those cout statements in there just so you can see how they work. Hopefully it's not distracting too much about what's going on. The important part is that you understand how this code works, and this will give you a good start for resource allocation in C++.